So what I'm looking at today is right here in our op-amp module, Tinker10, the active rectifier. And it's very familiar because I basically cut these images out of the active rectifier op-amp lesson. I'm just going to build this in Tinkercad and rectify a signal. So what I'm going to do is I'm going to build an active pusher. I'm going to build an active puller. I'm going to run them into a summing amp. Well, I'm going to invert one of them, run it into a summing amplifier, and get my output on an oscilloscope. So I'm just going to be building these things. It means that I'm going to need, at a minimum, I think I'm going to need, at a minimum, 4 op amps. So this thing's going to be crazy with op amps, which is why there's a type of integrated circuit that you can buy that is a larger chip. That is, instead of having 8 pins, it has, I think, 14. And it has 4 op amps on board. So you can use one microchip that has many op amps in it when you're building a circuit that requires many op amps. So the first thing that I'm going to do in my Tinkercad is I'm going to build this pusher. And once again, I'm going to jump back and forth, but I'm going to look at the things that I need. I need a resistor, I need a diode, I need an op amp, I need an AC source, and that AC source needs to be grounded. So I'm just going to go ahead and come to my Tinker. Going back, I think I already started a new Tinker. I'm only building the one circuit, so here it is. I'm going to go into this one. So many beautiful circuits that I've built so far, and a little bit of sadness for not having been able to do them, to actually build them, but maybe there's still hope for us, I don't know. Tinker10, what we're going to call this. And I'm going to pull out the breadboard for this. I have so many op amps going down for this thing that I'm going to, oops, I'm on the base, again, I'm on the basic components. I need to see all components. I'm going to go for the large breadboard on this one. So I'll take this breadboard here, drop it. Drop it down like that. That's good. Now, what are the things that I needed? I'm going to need a power supply to power my op amps. And I'm going to need that power supply to be positive and negative values. So I'm going to set a power supply here, but you know I'm going to need another one to create the negative values. And I'm going to have to rethink that all over again because every time I do it, I feel like I need to figure out again how to do it. I'm going to need a function generator. This is my AC source. It's going to give me the sine wave that I want. I'll set up the values for that. I know that I'm going to need a resistor. And I'm going to need that resistor to be 10K. I know that I'm going to need an op amp. I am not doing this very efficiently because there's my op amp. I'm going to need an op amp, and I'm also going to need, pardon me. I'm also going to need a diode, and the diode's all the way at the top. So I'm going to, all this stuff just to get my pusher put together. So I'm going to take positive here, and I'm going to take positive and hook it up to positive, and I'm going to take negative and hook it up to negative, and down here I'm going to take negative and hook it to positive, and I'm going to take positive and hook it to negative. And this is this strategy that I worked out how to make force Tinkercad to give me negative voltages. Of course, I have to connect my negatives together. I have to connect my negatives together. So I'm going to hook black to black on this side, and this is at 12 volts, and so this forces this negative to go to negative. Well, I don't know what voltage I'm going to make it. I think I'll make, what the heck. I'll make it 12 volts. Seems good to me. I'll make this 12 volts, or negative 12 volts. No, 12 volts. I can't make it negative. That's the whole point. These are the typical voltages that you use for these things. So that is for op amps. Op amps typically use 12 volts. There are op amps that use different amounts, and so I'm always going to consult my data sheet to tell me what voltages should be what. So I've got that hooked up. That's real nice. Maybe we'll do some wire colors today because I'm only doing one circuit. I have a little bit more time to be careful here. So I'm going to do some wire colors just to amuse myself. And I'm going to actually label these wire colors backwards because I've wired the thing up backwards in order to create the negative voltage. There we go. All right, so I've got the voltage that's going to power this op amp, and I also need this scope here. So I'm going to go from the negative on the scope to ground my scope out. That's what I would have to do in the lab. And then I have this positive here, which is my signal that's coming in. What does my activity have to say about the signal? Well, the signal's 1 hertz. I don't think I really care. In terms of voltage, I'm going to go ahead and have a look at what the swing voltage is on this. This is an amplitude of 5 volts. I think that's a little high. So I'm going to make it 1 volt just for giggles. I'm going to set its DC offset to 0. I don't know why it sets the DC offset to 2.25 volts by standard. That doesn't make any sense to me. I'm going to go sine wave on this thing because that's familiar, and that's quite lovely. Now I need to build the pusher part of this circuit. Well, my signal is going to go right into my op amp. So the first thing I need to do is throw my op amp down and get it powered. So I'll take this op amp, and I'm going to put it right about here in the field so I have a little bit of left to right to work with. And it needs to be powered. Here's the plus power. You know what? I'm going to move it over 1 so I'm lined up with the holes like that. This is really convenient to go plus power and to go minus power. Notice that I went red to red on that. So I'm going to just, for giggles, I'm going to mark that as red. And this is actually my negative red. This is my negative 12 volts that I'm running the negative power. So I've got positive power and negative power. That's great. Now I'm running, I have to go back and consult my pusher again. I am taking this signal in to the non-inverting, because that's a plus sign there, taking it into the non-inverting. And so here's my signal, and the non-inverting is right there, the plus 1. So I'm going to take my signal and jump the gap here to electrically connect this with this. So jump the gap like that. And then I'll come way out here, I guess. I don't know. I'm making this up as I go along and take it right to there. So now I have my scope signal, or my frequency generator signal, my signal source is going into the plus terminal on the pusher. Not done yet, because I also have to take the output and bring the output all the way around to the inverting input. And that requires a diode, and the diode needs to face away from the output. Well, I want to do that in the neatest way possible. So I'm going to take this thing, I'm going to try something. I'm going to flip this diode around, and I'm going to hook it up right here. The reason why I'm doing that is there's my output. So my output is going through that diode and coming to the cathode here, and then I'll just jump over to here and then jump over to the inverting input. I feel like that was the quickest and cleanest way to get me from the output around to the inverting input there. So I've come around from the output, I've come around to the inverting input, but now that inverting input also goes through my 10K to ground. That's easy to do because here is my 10K and here is ground, and bang. Notice that this resistor is going to the black here. This is the 0 reference potential. That is ground. This resistor is 10K. That is my pusher. Well, sure, great. I have a pusher. I also need a puller in order to accomplish this. And of course, I'm referring back to an assignment that we've already done, because this thing's already built and there's video on how that got constructed. I'm going to bring this in again, and I'm going to make sure I get it lined up so things are going to be handy. I think that's going to be a good spot to put that op amp. And now this op amp needs to have, oh, that's not good. Delete. This, that's not good. Shadley, you can do it. I know I can. Needs to be powered. So I'm going from, I'm going to make this red again. I'm going from my plus 12 into my plus power here, and it needs to go to the negative power here, the negative voltage. So I'm taking it all the way to the outside here, to the plus on that, and make that red. There we go. So now I've got another another powered op amp. But now what I'm going to do is I'm going to build the same thing again, but it's identically the same, but this resistor will be the same. But the diode, I'm going to install the diode backwards. This diode goes from the output back around, so it feeds back in the positive direction. So this diode is letting this op amp push. But if I take the diode on the next one and I put the diode in the opposite direction, which was actually the key to answering that, I hook it to the second terminal here, which is the output terminal. Notice the diode's in the opposite direction. That's going to allow this op amp to pull. And so I'm just going to configure these wires around it identically the same. And you know what? I still need signal going into the plus. Now here's kind of a gray area for me. I'm going to do something that's a little bit dubious. If I wanted to be completely honest about this, maybe I should set up another frequency generator to drive a fresh signal into it. Two things. One, my signal generator should be fancy enough. Lord knows I paid enough money for it. It should be fancy enough that if I hook it to multiple things, the output of the frequency generator won't droop. It should be designed in such a way, the circuitry inside my frequency generator should be so awesome that if I plug it into multiple things, it won't droop. And also, this is a simulation. So I think the input signal probably doesn't droop. That's my guess. So I'm going to take the input signal that's going into the positive or the non-inverting input here, and I'm going to take that signal and also take it over to the non-inverting input on this. So I'm using the same input on both my pusher and puller, and I think that's okay. I'm getting a little cocky off of yesterday's success where I built a thing that I didn't even have any idea if I'd be successful at it or not. And what do you know? I did it. I need to go ahead and ground this. That looks a little bit funny because this wire is under this wire, or this resistor is under the wire. Yeah, I don't think it makes any difference. It's going to do just fine. So there, I have a puller. So I have a pusher. Right next door, I have a puller. And now the pusher and puller, the outputs from them, which is right here. This is one output right here. What am I going to do with it? I'm going to take that output. I'm going to bring it over here. Why not? And this output, which is right here, are going to go into a summer. I'm a little weirded out by what I just did there. It's a little bit premature, but I wanted to get the output of this op amp and the output of this op amp to land in roughly the same spot on my breadboard. Let's see what I'm actually going to do now, because these are going to go into this summer. Yeah, I have to be careful because I've got these two 1K resistors. Before I bring the output of the pusher and the output of the puller together, I'm going to throw these resistors in here. These resistors, the 1K and the 1K, are actually acting like a voltage divider. When I make them equal, it means give me equal parts of each signal. Right? So I'm going to be equal amounts pusher and equal amounts puller going into my summing amplifier. So I need two 1K resistors, and then I'm going to configure an op amp just like if it were an inverting amplifier. Notice that I'm going to go into the inverting input, and the non-inverting input of the operational amplifier is grounded. So I need two 1Ks, and I'll put a 10K over the top for the feedback of the non-inverting amplifier. Here I go. So these come off as 1Ks. They're 1Ks by default. But for my purposes, it would be really nice to rotate them horizontally. So I'll give them 3 clicks of rotation like that. And I'll go with this one. And I'll go with this one. And they are still staggered one against the other. They're still off by one. So I'm going to drop a little jumper in here. So now these two resistors are coming to the same place. They're both coming to here. I just needed a little stagger jump, a little jumper to get me all lined up in the same place. So this pin right here is the one I'm going to take into the summing amplifier. It's the one I'm going to take into the op amp. A little bit of turkey that's going on with that is, I don't know why I just said that, a little bit of turkey. What kind of expression is that? Anybody got Thanksgiving on the ring? What? Oh, when I drop my next operational amplifier down, the inputs are going to be on the bottom side. So I'm going to have to jump across my board, but that's okay. Going to need another op amp for my summing amplifier. So I'm going to go to my menu here.
Are both those resistors 1K? Or are they 10K?
They're 1K. I think they come off 1K by default. Yeah, they're 1Ks.
Oh, okay.
It's good to test me on those things because I'm prone to screw up. So here's my next op amp. This is the op amp that's working as my summing amplifier. And it needs to be powered. So once again, I'm going to drop in some power cables, effectively plugging in my op amp. And so I'll do this. Boom, boom, boom. There. Now my op amp has power. Sehr gut. Yeah. Now, just go back for reference here. The outputs from my pusher and puller are getting summed together. They're coming into the inverting input here. So here's where my outputs come together through these two 1K resistors. And this is really a classic case, isn't it, of these just not looking anything like what it would look like if I build it in iCircuit. So it takes a bit of intelligence to follow the circuitry along. This is like when you look at a circuit board, you're like, I don't know what the hell it does. You have to follow all the paths, and you have to understand that even though the geometry isn't pleasing, that it's doing the thing that you're supposed to be doing. So I'm going to go here to the inverting input. Why mess around with it? There you go. Into the inverting input. Now, my output feeds back to the inverting input through a 10K resistor. So I pull off another resistor here. I make it 10K, and I'm going to rotate. That was just an undo I just did. I keep hitting the undo instead of hitting the rotate, and undo was the undo select, which is okay. Rotate, rotate, rotate. My output, I'm going to take a resistor off the output. That's the output pin right there. And this output is going to feed back to the inverting input. That's configured very much like an inverting amplifier would be. And all I have to do to finish this up is go positive to ground. So I want to go from my positive input here, not my positive input, but you know, the non-inverting input. I want to go from there to ground. Notice I'm going to the black row, not going all the way outside. I'm going falling short of outside there. So there's that. Here is my ultimate output of the thing. So I'm going to take a pause because actually, as it happens, I'm not done. But I'm going to take a pause right now at this stage, and I'm going to have a peek at my output and see what it looks like. So I'm going to go down here and grab an oscilloscope off the rack and put it in the vicinity of my output, which is coming off right here. And I'm going to take the positive terminal of this thing and go for the output to see what the output of this stage is. And then I'm going to take the negative terminal and go to ground. And I can probably shift this over so it looks pretty. Oh, isn't that lovely? Now, I'm not starting the simulation yet. What I'm expecting to see is my pusher and my puller, but both inverted. So I'm looking to see a dip, like the bottom part of a sine wave, and then the bottom part of a sine wave, and then the bottom part of a sine wave. And that really relies on me having built this correctly, and for the electronics being correct, and for Tinker10 being sophisticated enough to handle it. There's a lot riding on this, and I start simulation, and I see what I get. And that is the output that I expect. I expect only the pushes. I expect only the top of the signal, only the pushes. So I'm going to take this voltage, and I'm going to run this voltage amplitude up to something near the limits of this thing. Since I've got a 15 volt swing, I'm going to run this voltage, oh, not to 110 volts. That's not going to work. Hang on. Up to 10 volts. I think she can handle it. She cannot handle it.
I just passed my Tinker10 back.
You're having a little bit of microphone struggle there.
Tinker10 crash.
Wah, 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 wah. That's what you sound like. I have to repower this thing. And I have to repower this thing. And I'm going to take the output from this thing and go to there, just like I did before. I'm going to take the output of this thing, the actual output this time, and go to there, just like I did before. And now I have reconnected the things that I disconnected. I'm going to go for it and look at my output again, because I'm running out of time. And I'm going to start the simulation, and oh my gosh, I have I have what I wanted, believe it or not. Shadi, you wanted this? Yeah, except it's so distorted. The distortion is a surprise to me. I wasn't expecting to see distortion at this point. I still need an inverter substage at this point. But what happened there was I was taking the output from the pusher and the puller. I was taking the output before the diode instead of after the diode, which is what caused me that problem. So now what I have is I have the pushing peaks inverted. I have the pulling peaks, which are already inverted. And now the whole works is inverted. So the very last thing I have to do to finish this off is I have to add an inverter on the end of it in order to get the signal fully rectified and flipped over. I only have 3 minutes left, and can I do it in 3 minutes? Well, probably not. Am I going to try to do it in 3 minutes? Definitely am. So I'm going to drop another op amp down here. I've got to power it. Bang, 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 bang. It's powered. I'm going to take my output signal from here, and I'm going to run it into the inverting on this one, like that. And I'm going to drop a resistor because, oh, no, Shida, you screwed it up. Oh, God, no. Spent all that time fussing around. What's happening? I need a resistor to go to my input, and I'm happy to use a 1K to do it by default. Bang, just like that. Oh, look how perfect. And then I need another 1K to come over the top, all I'm doing is adding on an inverting amplifier. So I'm going to go from the output around to the back to the inverting input. I'm going to take the non-inverting input and ground it. And now my input, or my output is actually coming from right here, the output of the last stage. So what I'll get is that last oscilloscope signal that I had. I'm going to get that inverted. Is not a very, holy smokes. Yes. Full wave rectifier at the last second. Boy, do I love coming across the finish line at the last possible.